Hi friends, welcome to my YouTube channel. Hope you all are doing good. In the previous video, we discussed about the physical characteristics of water, such as turbidity, temperature, color, taste and odor, and also we discussed about several impurities that are present in water. If you haven't watched that video, please go and check it out in my channel, as that is the prerequisite to watch this video. Before starting this video, if you like this video, please like, share and comment to this video, and don't forget to subscribe to my channel. So, coming to the main part, we have chemical characteristics to discuss today. So, we have total solids. It can be found by evaporating a sample of water and weighing the dry residue left. The permissible total dissolved salts is 500 to 1000 ppm. Suspended solids can be found by filtering water sample through Wattmann filter, paper number 44. See here we have, as we discussed in the previous video, we have suspended matter and also dissolved matter in the water. So, suspended solids are those which can be seen with our naked eye, and dissolved are those which are completely mixed with water. Whenever we are evaporating the water will be evaporated and the dry element, the dry residue will be left. Whatever the dry part is there, that is the total dissolved salts. That should be from 500 to 1000 ppm. These are the acceptable limits for that. We also have suspended solids, that is we can see with our naked eye. So we can just simply get that by filtering it. So we are using a Wattmann filter of 44 size. Okay, we are using that. By filtering that, whatever the material that has been left on top is treated as suspended solid. Okay, coming to the second part, is pH of water. We know the pH is nothing but the indication of the hydrogen ion concentration, that is the negative logarithm of hydrogen ion concentration. I am telling you the pH scale is from 0 to 14, and whatever the elements that are scaled less than 7 are called as acidic elements, and the elements that are more than 7 on the scale are alkaline in nature. Okay, for water, that is the potable water, we have the permissible limit from 6.6 to 8.5, and pH is measured by potentiometer and calorimetric method. These are the standard methods or meters used to measure the pH of water. And we also have a general litmus papers to measure if it is acidic or basic in nature, but if we want the value in general, we have to use this meters or methods to this. Next, we have hardness. A characteristic which prevents formation of lather or foam with soap is called as hardness. So, why do you think formation of lather is important? We have some effects of this, like corrosion of pipelines, scaling of boilers, food becomes tasteless, measured in terms of ppm or mg per liter of CaCO3. Okay, see, these are all the important points I've noted down just to show you. Like these are all very important for in terms of competitive exams mainly, or any other semester exams. We have all the important points noted down. We have jotted down all of them. So generally we have corrosion causing because of this hardness, and scaling of boilers, that is the bottom part of boilers in large number of boilers in industries. This has become a major problem, this because of hardness. And food becomes tasteless when the water is more hard, this will be caused. And also we are measuring it in terms of ppm, that is parts per million, or mg per liter of CaCO3, that is calcium carbonate, and measured by EDTA test. EDTA is nothing but ethylene diamine tetraacetic acid. In titration process, EBT, that is eriochrome black tea, is used as indicator. Remember, whenever we are measuring hardness, we have standard EDTA test. EDTA is nothing but ethylene diamine tetraacetic acid. We are using another indicator in this, that is EBT, eriochrome black tea. Remember these two terms. Okay, and we have the permissible limit. If hardness is less than 75 ppm, it is soft water. Greater than 200 ppm is called hard water. And drinking water, we generally need a hardness of 75 to 150 ppm. Okay, we also have types in this, that is temporary hardness or permanent hardness. The temporary hardness is termed as carbonate hardness because of the carbonates and bicarbonates of calcium and magnesium. And we also have permanent hardness. The second type of hardness is called as non-carbonate hardness, that is caused by chlorides, sulfates and nitrates of calcium and magnesium. Okay, we also need to remember the standard values along with the types of hardness. And temporary hardness can generally be removed by boiling of water. Next we have chloride content. Chlorides are present mostly in combination with sodium, that is NaCl, sodium chloride, which imparts salty taste. We know sodium chloride is nothing but salt. Chloride content in treated water should not exceed 250 mg per liter. Okay, this is the acceptable limit of chlorine. Next we do have fluorides. They may naturally occur in water. Fluorides up to 1 mg per liter in drinking water is safe, but if concentration exceeds 1.5 mg per liter, it is to be treated as unsafe, which can cause fluorosis. Okay, fluoride if more in content, that is more than 1.5 mg per liter, can cause fluorosis. We have nitrogen content. The presence of nitrogen in water indicates the presence of organic matter occurring in the form of free ammonia. See, we generally have four types of nitrogen content. We have forms actually. We have states of this nitrogen. The first one is free ammonia. That is, it is the first state of decomposition. Okay, free ammonia is nothing but the first stage. And we have albuminoid. This indicates decomposition of organic matter started in the first stage, that is just the first state of decomposition, whereas the decomposition just started in albuminoid state. Next, coming to nitrite, the presence of partially decomposed organic matter, that is, it is a bit more decomposed in this state. And nitrate, that is, it indicates fully oxygenated or oxidized organic matter, that is decomposed. Okay, we have four forms of this. Even these terms are very important for the competitive exams. And excess of nitrogen content causes blue baby disease. In technical term, we call it as methemoglobinemia. And coming to the last type of characteristic, that is biological characteristics. To study about the presence of virus, algae, protozoa, bacteria, we call this biological characteristics. We are just studying about presence of these elements, these virus, algae, protozoa and bacteria. Bacteria are single-celled microorganisms of size 1 to 4 microns. The disease-causing bacteria are called pathogenic bacteria, which are responsible for waterborne disease. That is, the diseases caused because of water, like infectious matter in water, like typhoid. In bacterial analysis, the following tests are done: total count test, E. coli test and member filter technique. These are the three types of bacterial tests that we generally use to determine this presence of this bacterial elements. And I told you some waterborne diseases. We have some bacterial infections and viral infections. Because of virus, they are viral infections. Because of presence of bacteria, we have bacterial infections. So, these bacterial infections are typhoid, diarrhea, cholera. And viral infections are infection hepatitis, gastroenteritis. And we are done with this biological characteristics. Generally, we are mainly asked about physical and chemical characteristics. More about physical characteristics though. So that is it for this video, guys. If you like this video, please like, share, comment to this video and don't forget to subscribe to my channel. I appreciate you watching this video. Thank you.